Hello and welcome to Ethical Hacking and Penetration Testing. This is Chapter 7, Wireless Network Security. So the topics that we're going to be covering are breaking web encryption, rogue access points and attacks, wireless sniffing, and protecting wireless networks. So breaking web encryption. This is something quite fun to do at home. Unfortunately, we don't have any web-enabled devices here. However, I do have a bit of a tutorial on how it works. So hopefully we should all be familiar with something like Backtrack or Kali, and within there is a full S-Node suite that will allow you to do this. So if you start by opening up a shell in Kali or Backtrack, and you do an mon-ng, you do need a wireless adapter for this. If you're running it as a virtual machine and you're trying to use the internal adapter of your laptop, that probably won't work. You need a USB adapter ported through to your virtual machine that gets picked up as a WLAN 0 interface and not presented as just an ETH0 interface. As you can see here, this has got a chip, the correct chipset and driver. It's quite a powerful card. You don't need one that powerful, you just need one that supports packet injection. So you've discovered that you have a WLAN 0 interface, and if you do an aerodump-ng WLAN 0, it will start running aerodump on that particular interface. And as you can see here, it will show up. There is one networking range with two devices connected to it. So you can see here you have the BSS ID of the network, which is just the MAC address of the router. The amount of beacons it's sent out, the amount of data, the minute it's nothing, the encryption types, and here are the MAC addresses that are associated with the MAC address of the base station here. So now, if you run an aerodump-ng -w to write, you want to write it to a file called web. We can see that it's running on channel 1, so we do a -c1 here, and the BSS ID of the router basically, and then the interface you want to run it on. This ensures that you're only going to capture the information you need from that particular router and no other ones around it. So that's running in the background. You can see that there is some data here, so it is capturing data. It is writing to the particular file that we named before, just called web. So you can do some deauthentication attacks, which is basically trying to send association requests to that router, and we're hoping the router is going to reply and say, "What password do you have?" And we give them a password, and they say nope. Or hopefully, if we can deauthenticate the user who does have the password, we can capture the password being sent over the airwaves before it reaches the router. And here we have AirReplay -3 being -3 deauthentication requests to that particular router. And here you can see the ARP request being sent, so we should see the data usage on that router port as well. Here we go, data has hit 4,144 packets. Hopefully within there should be some reconnection attempts, etc., which will allow us to try and crack the web. Still going up, 30,099, perfect. So if we stop it, you can see here there is a rep-2 cap file. The cap file is what we need to be able to crack it. And if we run aircrack -ng, and then we use the web file with a particular word list. Kali and Backtrack do come with their own word lists, however I'd thoroughly recommend either creating your own. There are tools you can get to create your own, or just downloading one. And this is going to run through as many permutations as it can to try and figure out what the actual key is. And then hopefully, after a little while here, this only took 1 minute 7 seconds, it found the key. Now you may think that's all fair and well, but I don't have a device that can do that. Well, you kind of do. You can buy a device very cheaply. You can buy a Raspberry Pi. It can be used for web cracking or web capturing. You can just use your Raspberry Pi to do the initial capture in a remote location. It can be running on a battery sitting in a bag, trying to capture as many authentication keys as it can. Some people go war driving with these things, and they have GPS antennas on them, and then they'll drive around the neighborhood. They go home, they plug it into the computer, and then they'll be able to see what wireless networks they could see at what location and what the security was, and then they do another run around and do some deauthentication attacks, try and capture some caps, and then go back and put it on a more powerful machine to crack. So if we have a quick look at how we could set up a Raspberry Pi as some kind of rogue access point, which works brilliantly for acting as a proxy between a user and their intended destination for you to capture as much information as you can. So to do that, we're going to use something called Kali Linux Evil Kali Access Point. I know it sounds a bit kind of scary, but it's not really. It is just an evil access point. You can create a distribution of Kali to automatically start this. So if this is going to be the sole purpose of your Raspberry Pi, then I'd thoroughly recommend looking at the software. So the first thing that we had to do is to load a few services. You can use host APD and DNS mask. It's pretty simple to set up. DNS mask will allow you to quite easily control spoofed DNS queries. And once everything's installed, we can configure DNS mask to serve DHCP and DNS on the wireless interface, and then start the DNS mask service. So this is the config that we're going to be using here. It's nothing too complicated, to be honest. You're just editing the host APD file, the conf file. You're putting in the DHCP ranges, the interface, and the automatic address. I know it's hashed out there, but you can give somebody kind of a landing page or whatever you want. Chances are most people will have their landing page set to either Bing or Google. You can force them to go to Google. It just makes it look a bit more genuine, and it's less likely to kind of throw up any red flags on a user part anyway. Log facility varlog dnsmask.log, quite handy if you want to go back and see what you've been doing. Now, how do you get this data ashore? Well, you can use a 3G connection. If you don't want to actually connect to the access points that the user wanted to go to in the first place, because that would kind of leave a bit of an audit trail somewhere where you may not have access to delete logs, etc. Why not send them out a 3G connection? It'd be far simpler. It's surprisingly simple using the GNOME Network Manager GUI interface. You can just add a new 3G connection and go through the automated wizard to get you online. In only a couple of minutes, really. A lot of the Huawei devices are already configured to work just out of the box. So once connected, you can see the new PP01 interface pop up, as you can on the left here. It just shows it was a GSM connection, now providing you with internet access. Alternatively, the setup can be performed on a command line using VW dial. So now that we've got the WAN connection set up, you can move on to setting up the actual wireless access point itself. And I know you might think you're going to run out of USB ports here, but if you've got one for a WLAN connector and one for a 3G connection, you'll be okay. You can use powered hubs, but obviously if this is going to be sitting in your bag, you don't want to drain too much power because it's going to be running from a battery. The new Raspberry Pi, I'm not sure if it's out yet, does have 4 USB ports, so just be mindful of the amount of connections you need to complete the task. So the wireless access point setup, it's a real breeze using host APD. You can configure an IP for the wireless interface, you can configure IP table rules for NAT, and then you can configure the host APD service to use your wireless interface to run an access point with the SSID of something like free Wi-Fi. Once the service is started, a wireless network called free Wi-Fi should just pop up, and anyone connecting to this network will be routed through your Kali box out to the internet over 3G. So what's next once you've done that? Well, you can kind of do anything you want, really. You can sniff traffic, you can use some man-in-the-middle tools like EvilGrade and SSL Split. So using a live build, you can create a custom Kali Linux ISO image that will boot up into kind of a rogue access point mode. Certain elements such as the wireless and 3G interface names, which is WLAN0 and PPP0, would be pre-configured during the live build process. You can go ahead and set it up yourself, so you just have to turn on your device and it will just work. So we tend to do is selectively spoof DNS queries and redirect users to our own phishing sites with sufficient information to make them think it's believable. So basically, that would mean you've got some spoofed DNS queries in there. To say, instead of going to facebook.com, it would go to the Facebook page that you are hosting, and as soon as they put their details in and send it off, they would get a reply back saying, sorry, your password's incorrect, by which time you would forward them onto the real page anyway. So the next time they put them in, it would go to real Facebook. Chances are the first time they put the password in, it wouldn't be wrong, but because it was on a page hosted on your device, you've just seen in plain text what their passwords are. Quite simple and very effective.